I'm Ketra, and in this video we are going to learn about the basic MATLAB programming. And the first one is we are going to learn about the basic matrix operation. In this first one we are going to create a simple vector by using this syntax. And the second one we are going to create another simple vector which is going to be created by the from the original simple vector, and we are able to create a 5 by 5 matrix by using a semicolon between two matrices, and we are able to write the transpose of a matrix by using this syntax. By using the star operator we are able to write the product of the two given matrices. By using the delta star operator we are able to give the product of the corresponding elements of two matrices. By using this syntax, we are able to create a column vector from the elements of the given matrix. And by using this syntax, we are able to give the mth row through nth column of the given matrices. And by using this syntax, we are able to create the submatrix taking the inner subpart of the matrix X. And by using this syntax, that means by giving some value, by giving the null operator to this one, we are able to deal with the row and column column of the given matrix. So when I run this, I would get the values to be like this. Next one is that in here I'm going to plot the elementary signals by using the plot, subplot, and this temp signal. So for this elementary signals I'm using the impulse one, and the next one is unit step, the next one is that sinusoidal ones, and the next one is the exponential function. For this subplot 3 means one I'm using the 3 by 3 grid, and one implies that I'm using it to the first one, and here 3 subplot 3 implies that I'm using 3 by 3 grid, and it implies to the third graph. Grid down means while we are having the plot we would have the grid in it, and axis type is that it is used to have the same aspect ratio for the both the axis. So when I'm plotting this, I would have got the graph to be like this. I've got the graph to be like this. And for the next one is that I'm saving and loading the files in different formats. The first one is that of this, the syntax of this one, I can store the files in the .mat and .text and .xls forms. And for the MATLAB to read this for files, it should be in the form of the minus ASCII form. And when I use this syntax, the MATLAB will be able to give the output of the file. So when I run this, I would get I would be able to read that file, which means that the file would be in this format. And next I'm creating a structure. By using this syntax we are able to create the structure, and by using this syntax I am able to create a new structure, and by using this syntax I am able to get the by using this syntax I am able to get the attributes of the given structure. So this is the answer for that. And I'm now appending the value of a variable. For this, when I have some variables in a given file, for example I have only x and y. Now I have to append z. So by using this syntax I am able to append z. So when I have this syntax I am able to read what the file contains, example .mat at the last. So this is this one. And coming to the next one, here I am using the read cell and write cells. The read cell and write cell command is used to store the vectors. So by using this syntax I am able to read and write the vectors, and by using the write matrix and read matrix, these are used to store and read the matrices. Here I am using the magic squares. So when I run this I would be able to get like this. Here is this one. And next, coming to the next one, in MATLAB we are able to read the audio files also, and handle.mat is the included library one. So I'm giving the file name to be str.wave, and the file name, it contains y and fs. So I'm reading that audio file and clearing the f and ys again, and I'm declaring about again like this using this syntax. Now by using this syntax I'm able to read that audio file. So while running it I would get the audio that you can listen. by using this syntax I could write the quadratic expression. And also moreover we could learn this one also, we are able to draw the plot of a quadratic function. So when I run this, I would get the graph to be like this. And from the above quadratic expression I could find the roots of the quadratic expression to be this one. Okay, now coming to the next one, this one. These are the basic commands of the MATLAB. First one is the replem, which means the repeat copies of the array elements, and I use this attribute, this syntax to have in this. From this attributes I'm copying v for the 3 times, and next repmet is the repeat copies of the array, and I am able to repeat the copies 2 times copies of the array for 3 times. And identity I is used to create identity matrices, zeros is used to create zeros, and in this form, the in the given attributes we are able to form the given of the given size, and once is used to create the one unitary matrices. And for randy we are assigning the random variables of the random variables, random values. And for reshape we are reshaping the array. And for cat we are concatenating the arrays. For example, in this syntax we are able to concatenate a and b. And for next one we are horizontal, for horse cat we are horizontally concatenating, and for vertical cat we are vertically concatenating. And for diagonal we are creating diagonal matrix or to get the diagonal elements of the matrix. And for block diagonal we are making the diagonal matrix of the one block to the other block. For flip parallel we are flipping a matrix from left to right, and flip ud we are flipping a matrix up and down. And for rotate 90 we are rotating a matrix. For trill we are making the lower part of lower triangular matrix. And for try u we are extracting the upper triangular part of the matrix. And for permute we are permuting a array dimensions. And for circ shift we are shifting the array circularly. And for the length we can obtain the length of the largest dimension. For example, for c of n comma, the length of c will be given to be the 4. And for size of the array, and from the size we can size. And for n dimensions we can number of array dimensions. And for numeral we can count the number of the array elements. For isempty we can determine the whether the array is empty or not. So when I get this one, I'm able to see this. And for isempty I will get to be the logical one, either logical 0 or logical 1. And coming to the next one, I'm here executing the while loop and for loops, and in this we are using the continue and break also. And for initially while we are using while loop, for every statement we have to use this and. Initially for when a less than 10, when I want to print 10 for a, it prints to be like this. So when I run the code I will get it to be like this. Yeah, here it is. A equal to 5, A equal to 6, A equal to 7, A equal to 9. And similarly for the for loop also display, we also displays me the values of v. And for the nested loops I will get for the for loop in for loop or while loop in while loop. In that only we can use the continue also. For this continue we can skip the remainder part of this body. If this one is true, and then I can skip this and other also. And for the break statement with terminates the loop. So when this happens, then this directly comes off this while loop. And that's all for the next one. Coming to the next one, and this is the decision making loop. This is the if and statement, if else and statement, if else, if else, if else statements, and the next are if statements. For this, if this one in the for the if statements, if this condition is to be valid, then this base will be executed. And for if else, if this, and in for if else case, if this one comes to be wrong, then it comes to be an else case. And for now, in if else, if cases, the statements would be increased. and if this case is proved to be wrong, then if else, then this case will be checked. If this case is also proved to be wrong, then this case will be checked. Either all, then this case would be checked, and which would be given to be the output. And in the necessary if else cases, first if this one is to prove, if this case is to be proved to be true, then it goes into this one, otherwise it goes to this. If this one is proved to be true, then it goes into the formula of, and it again follows the if else conditions. And coming to the switch case, in this switch case, if this one is proved to be true, then this one goes on. And if this one, in case one I have given equal to 5, so in switch case, if this e1 equals to, so this equals to 5 or e, then this place would be displayed. And so on. In the next switch case also comes to be the same as if in the if else cases. um, Thank you.